Hello everyone, my name is Avkash, and if you have never created a neural network, or if you have worked on neural network but you find yourself not able to understand what is going on, or you are afraid of touching the concept or the content related with neural network because you feel it very hard to comprehend or understand, this is exactly the tutorial for you. In this tutorial, I'm going to show you line by line how a simple neural network is created, the smallest possible neural network, but practical. My objective will be to help you understand how you can start your journey with deep learning by understanding the neural network. And why it is important for you is that everything in deep learning starts with neural networks. So whether you are trying to work on unstructured data such as audio, video, music files, documents, etc., or you are working with structured transactional data such as shopping cart, loan, purchase history, etc., neural networks are going to assist you all the way. So if your objective is to get comfortable with neural networks, this is exactly the tutorial is for you. If you are an expert in neural networks, you may not find this tutorial very useful because I will be talking something really very early or preliminary stage, as well as my speed will be slow so that beginners or the starters can understand the concepts clearly. So in front of you are just the starter screen. We are going to get started with neural network. So what are the key parts of neural networks? There are three things you have to get started. You need to have some kind of input, then you need to have the output, and in between input and output there are layers. For a starter, there could be only one layer, or for experts, these layers could be hundreds and thousands in a complex neural network. But start happen with input and ends at the output. What happens between input, output, and in between layers? You feed input data to neural networks. Data flow from layer to layer to layer until output is generated. When output is ready, it calculates the error, which is the scalar value, and depending on your weights or biases, the error is calculated. Okay, and if the error is not something which is expected, when I say expected means the error is not reduced to a significant lower number, you are going to iterate that process all the time until you are achieving an error which is lowest possible and accepted. That's pretty much it is. So if you have looked into several blogs, people are going to create the perceptron, which is very first neural network, and you are creating in Python. That is really very good thing if you could get at that level. But today we are not at that level. We are not going to create this perceptron from the scratch. No, we are going to use the existing libraries such as Keras, TensorFlow, PyTorch, etc., whatever is available, and use them to get ourselves started. If we could get the concepts solid with us, we can go ahead and start looking into the building a very simple form of perceptron as a base neural network. So it means we have to start with somewhere. So let's start with TensorFlow and Keras. I will start from there. So I already have Keras and TensorFlow installed in this machine, latest one. So let's import the TensorFlow first. So import TensorFlow as TF. TensorFlow we have. Then once you have TensorFlow, then Keras is also there. And as you see that we need layers. So we will say from TensorFlow dot Keras dot layers. Usually when I do not type completely, I press tab, and if it completes, it means that particular module is there. Import input. So now we have input also. So that's all you really need in order to get us started. So now we have to define our input. So let's try to say that we are going to use our input, and that will be input of something. So when you are creating neural network, you are solving a problem. A problem has the data source, because when you are using machine learning, you need to start with the data. So the data could be rows and columns. If your data has 10 rows, it means, it has 10 columns, it means your input has 10 features, so your input will be 10. If your data has unstructured property, it means it's an image. If it's an image, then you have to provide that this data is actually image, so you need to provide the rows and column for every image. So in that scenario, your data could become a shape of whatever size you are starting. So you can say, I'm going to start with 128 by 128. So that's your shape will be, and that will be your input. So far it should be okay for you. So that's your input. Now you have to define your output. So you will say, this is my output is what type. Once you say you need to have an output, now you need to go look into input and output. In between is your layer. Okay, so now you have to define an output, and you will say that there is a layer, and layer is defined by their type. So it means that if we have layer, there is a definition of layer. So we can say, let's have the dense layer. Then you say, you will ask where this dense came from. We need to go back to look into the documentation, and here we have tf.keras, and here we have layers, and here you could see there are various types of layer available. Depending on how deep you would want to go, what kind of problem you would want to solve with neural networks, there is a type of layer associated with the type of problem and the type of data you are going to process. Here we are looking into the dense layer. And if you look into here, so this is just a regular densely connected neural network layer. If you do not have a proper idea where to start with dense layer. It's going to work with your unstructured data such as image, and it's also going to work with your transactional data such as shopping cart or purchase history or shopping history or house purchase, anything else. So we have output. It means that your output will be a type of dense. Okay. Now remember, your output you are going to define. So in majority of the case, your output will be the single entity. So you can say that is your output. And for every output, if you are going to look into the, you see here that dense layer has various property. So units is basically the number of, as you see here, the way the definition should be for unit, the positive integer, the dimensionality of the output space, what output you want. Okay. And you need to have the activation function. And if you do not specify anything, no activation is applied. It means linear. The function of x is actually x. What you are going to pass, that is exactly going to pass through. So if it's a dense layer, your output. Now, if you say, okay, is that everything? I think it is everything now. So now you have defined your layer output, which is dense 1. Everything is okay. Everything is perfect right now. But there is one problem right now. How you are going to connect input with output? Because input is separate, output is separate. Now you have to connect input with output. Means the input, the output of the last layer is going to be input for the next layer. And the way you are going to connect is that you just say that whatever this input is, I'm going to connect here. There you go. So I have connected this output from that input, and if I run, everything is okay. So even if you will not give this input, your output layer is defined. There is no problem in the definition. but there is a problem in connectivity. So in order to connect these two layers, you are connecting input with output. And that's where now these two layers are connected. So you have set input output, and output is the input coming in through. And it's a linear, no activation. Now what we can do here, we need to define the model, because now we have to pack this whole thing in some kind of neural network, and that is the model equals tf dot keras dot. So we have model, so we need to go model. Okay, so I didn't model, and now you need to say inputs equal input, outputs equal output. Now you have your model. This is your simplest neural network. And now what happens is that you would say, I need to check my model summary. There you go. Model summary is input none, nothing is coming into, it's start from here 128 by 3, and the next is your dense layer, and output is as it is. If you would want to save this network, you could say model dot save, and you just call it, I will define a file name, there is a reason for that, so I will say model name equals simple model dot h5. I have another tutorial where I talk about how to save model, and so please visit that tutorial and you will learn a lot about just like of dealing with these APIs and saving, etc. So model, we are going to save model name, and if we look into our local file system, we will see that there is a simple model is available. Just yesterday, I have created this tutorial where you could understand neural network from a code and its visualization. So please visit this tutorial, and it will going to help you understand how we are using this neural network visualizers. There are a variety of neural network visualizers I have used in this tutorial. Today we are going to use only one of them in our tutorial. So this tutorial is definitely going to be very helpful to go more deeper about it. So my request would be that please visit this tutorial, because that is going to be very helpful for you. Now we can come back to our own tutorial. So we have a utility called Netron. So input Netron. So I do have Netron installed in this machine. Netron is the utility where you could select a model and you can visualize its full network. So that utility we can use locally directly in your Jupyter network by importing it, and then you can say netron dot start, and you pass your model file. So model file is our model name, and that is available on local file system. So it can read from local file system because it is here, and we can say start on port 8081. Netron is going to start localhost, and as you could see here, I will close this, and it's available here. Its input 128. This is our activation is linear because we haven't defined any activation. So what I will do, I will move this tab and make this half a screen, so we will always going to have something visible, and now you could see, and that's very quickly we have saw our very simple network. So if you have never created anything like this before, this will be your starter. I will save it. Now we will try to experiment our neural network piece by piece. So we have seen that this is our input, this is our output, and output is, as you could see here, that's our dense layer 3 by 1 and bias. Because if you look here, these are the three inputs are coming into here. So what we could do is that at this point we can come and we can add one more layer here. So we just call it layer 1 equals, and we just call this layer is also the dense layer. Now we add this layer is actually the number of neurons is going to be 10, and I will define layer 1. So remember, when we have created input and output, the dense, which was the output, was the dense layer with 1 neurons. We connected input. It means if we want to connect this, we can take this input, we can move it here, and this layer 1 will become connection here. So now layer 1 is connected with input and layer 1 is connected with output. Now if we try to make our model is defined. Now this is the model of a summary of our model. Now you could see here that input layer and here, okay, and then the dense layer. Hopefully that clarifies you that we have added one more layer. Now we can save our model, and because model is saved to the disk, we can reload it here. So I will just reload this page and that will reload our model. If I will try to start here, it will try to give some error. It will say that the port is already occupied because this netron.start try to recreate this service on this port, and because this port is already utilized, it's try to give error. It gives an error. The other option is that you do netron dot stop, and after service is killed, so like you see here is stopping, it is stopped. Now 8081 is not running. Now you could reload it, and then it's reloads here too, and then you can close this. So it's a little tricky, but hopefully you get an idea. So now you see that we have 2 layers and 3 by 10, 10. So now you are getting an idea that this 10 by 1, 3 by 10. Hopefully that clarifies. What if you say that your shape is actually 3? Starter, everything, that's your model definition. This is your, now you see that 3, 10, 1. Let's save it. Saved, reload, and that's where it is. The activation is all linear right now because we are not defining any activation. But if you would want to define an activation, you could add the activation here. Activation equals TensorFlow dot, you have ReLU. There are several, so TensorFlow.nn, you always look into the documentation. CReLU, ELU, GELU, there is ReLU, ReLU 6, there is a softmax. So we have used ReLU. Our activation is ReLU, model is defined, save it, let's reload. Now you see here the activation function is added at here. So it means that we have added ReLU here. If you would want to add activation in this one too, you could say activation equals tf.nn softmax, save, reload, and there is the softmax. So you get to see that how we are trying to play with our layers. If you would want to add one more layer, you come here, you add layer number 2, and this dense layer have the 5. You can say that your activation should be ReLU 6 and it's connected with layer 1. Layer 2 will come here. Now we layer 1, layer 2 output model. Our model is defined. This is our model summary. Input layer, and then 10, 5, 1, and finally save, reload, and ReLU 6, as you could see here. But remember, you have to have understanding that what activation you are using. Basically, these are the switches, how the data will transmit from one layer to another. If you do not pass anything here, in that scenario, then linear will be used, and which is better if you don't understand. But if you are passing a linear, then there will be no transformation. So it is very important for you to know what is going on when you are building your network. But when you are defining the model and when you are saving it, you are getting this error, which is just a warning, because when we are saving the model, the TensorFlow is saying that we haven't set up any metrics because our model does not have any parameter. And in order to make that model useful, we need to set up the hyperparameters, these parameters which are very useful for model to be defined. This is just a network is defined, the step by how the building blocks of network. But the parameters is what they define the model property. So if we would want to define our model property, which we do not have listed here, and now I'm coming just there, after this model is created, we can set it up. We can say model dot compile. It means whenever this model is going to be compiled, we need to define its property. So if you would want to get what the compile function takes, what are the parameters, look into the TF Keras models. So you come here, TF, this is your Keras, and here is your model. And within the models, if you would want to set it up, model.compile, here is your model.compile, and you need to define. So you have to provide the optimizer, loss, the metrics you would want to pass, the loss weights, weighted metrics, run eagerly, steps per execution, GIT compile, and other arguments if there are. So there could be variety of properties, but for the sake of simpleness, we are going to pass just the basic useful or the required parameter. So we need an optimizer, so we can pass an optimizer here. And Adam is one of the very popular optimizer will be there. If you would want to learn more about optimizers, you can always look into the tf.keras, and when you look to tf.keras, and there are optimizers, and a list of optimizers are available for you, what their properties. So SGD, Adam, these are various optimizers available for you. So in the subsequent lectures, we are going to dig into each individual, and we are going to find out why we need to use one and what its usabilities are. So we have set up our optimizer, and if we try to say model.compile, yeah, so optimizer is given. If you will not select an optimizer and you say I want to compile our model, it is going to take the default settings, model summary, and we can save the model, reload the model here, and as you could see here that this is our model, and everywhere here when we are defining, those properties are not going to be available because those properties are going to be activated when you are going to train your network, train your model. And until you are not going to train, the compile properties will not even going to be active. Until then, your model network is still available because that's the scaffolding or it's a framework of information to be processed. So that's why that is still there. So the model properties are, even if you try to set it up here, optimizer is Adam, this is your summary, and you try to save your model here, reload, it's still nothing is being given to you. So I just wanted you to understand this is very important part for you. Okay, so we have decided optimizer here. After that, you need to define two more things, which is very important. You will say what is your loss. So there are various loss parameters available. You can choose one of that. And what will be your metrics? So metrics is an array. And in the metrics, you can provide what will be your metrics. So I will be using MAE. This is your model. Save, reload, and again. Thus your basic simplest way you have created a model and you have saved it. Now what I will do is that, what if you do not create a model in this format? You change your model type. You build the model, but you use a very different way to create the model, and then we are going to use that part. So we will select another Jupyter notebook. Okay, let's see, creating network. Okay, and just use what we really needed minimum. So we will have the TensorFlow, and we also need these two. So these are the two required modules for us to start our network. So very first thing, what we will do is that we will create the bucket, or create the model property. So we will say model equals df dot keras dot. Now you see here that we have various properties available here. So you see we have models. So we say models dot, and here are other properties. So we will say let's define a sequential model. And because I am running TensorFlow on my local machine on MacBook, so it's just giving you these warnings, but they are just benign because I already know that a limited or striped version of TensorFlow is available for Mac. If you would want to use the full version, it's better to use Linux or other machines where you will get the GPU enabled and full functional TensorFlow will be available for you, unless you want to recompile and do all that thing. So we have defined a model here, and if we want to take this model, and we can say model dot save, and here we will use the same our model file name. So model file name we have defined simple model, and the only thing I would just call it simple model new. That's our name, and model dot save will be save our model. And as you see here, that wait for model sequential have not yet been created. It means you created the model, but this is just a bag. This is just a bucket. There is nothing we have added. So we have to add something so that our model can be started. So very first thing we need to do model dot add. It means we are adding a layer, which is little different than here. Here we were creating free form of network. We defined input, we defined output, we will keep defining the layer, and then we were manually adding these layers. So for example, if I create here the layer 3, layer 3 is actually the 15, and I'm defining it that layer 3 is actually connected with 1, and 2 is connected with 3, and 2 is actually the last layer. So if you define 1, 2, okay, we need to define layer 3 first, then layer 2 first, and output, model, compile, summary. Now you see here that 10, 15, 5. So start from 10, then 15, then 5, and then finally. So even the way you are writing in order does not matter here. What is matter here? The connectivity between the layers. So it's a free form method of creating your network. And it's still, if you try to save your model and you reload here, you are going to get your model defined this way. So dense, 10, 3 by 10, 10, 15, 15 by 5, and 5. So the way you have defined. 3 by 10, okay, makes sense, okay, then 10, 15, 10, 15, then 15, 5, 15, 5, okay, and then 1. Okay, now we come here, we have to add something here. So when you are going to add something, now your structure is going to be called, which is definitely has to follow input, output, and layers. So we have to set exactly here. So we have to define our input. Input is already defined here. So input will be your shape equals, you can say, I'm gonna create the 512 by 512 by 3. So model input is added. Let's try to name is there, save it. Because you have added input layer, model is available now. We can look into simple model new is available at this point. And if we would want to see it, we can say import netron, and I could say netron dot start, and I will say load this model here and run on 8082. So this is 8082 here. So now we have both models. So you see here input 1 or input layer, and that's all we really have. The way we have created this model, we have added input layer. There is nothing so far. So little different than what we have done. We have created input, but the input was connected with the next layer wherever it was. Now let's add one more line. So model dot add. Now we need to add something here. So what we could say is that model dot add, we can say we are adding a dense layer. So let's see if dense is defined. Now we have to give the input. So we can say the dense layer is 10 model dot add. So if you see here, we need to define our model, adding the input, adding the dense, and then saving the model, and then reloading the model. So input dense layer. Now if this point, if you just come here and you add one more line of dense, and if you save this model, you see one more layer is added. It means this model is hot model right now. Hot means it's active. Anything you could keep adding here. Similar to that, when you are here and you are trying to build your model, if your model is available, you have to find a way to connect. But if you see here, your model is fully connected. So in order to break this link, for example, if you create a new layer 4 and 3 is connected with 4 and 4 is connected with the output, then you have to rebuild the output here. But here, when you are creating, your output is the very last layer, dense 1. So what I could do is that I could create this last layer as 1, and if I add 1 here, and if you see, if I save it, it's going to add 1 here because that is added at the very last. If I come and I can add one more layer here, and I can say 21, save, 21 is added here. So reason is that the way you are adding this network is that everything is being added the order you are adding. If you come here and you can say I would like to add model dot add, and you want to create a dense layer of 128. Let's add this, save the model, reload. Now you see that 128 is added here. So this order does not matter. What matters is that how you are creating your network. And if you would want to see your model summary, you can always see your model summary, model dot summary. So here your model summary. Same thing, if you would want to add the activation, you can always add the activation. So you can say the activation equals, you can say tf dot neural network dot value. Your activation is added. Now if you will save this, you will see that ReLU is added at the very last. It's not added because it's thinking that you are creating a model and then you are adding the layer at the very last. So the way you try to build this thing, you redefine your model, then you define everything, and this is not good. I will go ahead and stop it and redefine our model and save the model. And if we try to look the summary, now we have our model defined this way, and reload it. And this is your, and if you click on here, you will find the activation is linear versus here the activation is as defined by you. So hopefully this clarifies you that if you are trying to create a network, there are a couple of ways you could create and what you need to remember. And this was very important part for anybody who would want to start writing code for neural networks. Whether you are trying to solve the Titanic, very common problem which we have heard, or you are looking into that those heart disease detection, or there is a flower cytosa flower problem. They all inherently you have to work on your network creation, and this is simply you are going to create it. Now you can go and you can start changing your layer type, you can start changing your activation, and then I haven't came to compiler part because that was coming a little later when we have a training data. Right now we don't even have anything because today we are not going to have anything related with training, etc. So once you get these models, and as you see here that we have ability to load our model and look, and I always look into the model because this way it gives me very quick understanding of what is going on, how everything really look like. So we have understood the two different ways to create the neural network, but a couple of things are not clear for starters, and that would be very simple way to ask is that what is this 512 512 3, what is this dense 128? We already talked about that these are the number of neurons in this layer, and this is the shape, and what is the parameter 3. So how this thing is really being decided, what is 3, what is 1, we need to look into that one. Second, if you look into this property, when we were looking into model summary, what is this parameter? So a couple of questions will be coming to the viewers or the reader's mind, that how these parameters are defined, how the connectivity between the layers is being established, okay, and what happens when your network is moving one layer by next layer to the next layer. So let's try to add one text or markdown shell. So we need to get a concept of feed forward network. So what is feed forward network? So feed forward network is that when you are taking the total number of neurons available in the layer and you are processing them to the next level of layer. So if you see here that between input and the layer 1, the number of biases, so the bias here is 3 when you are starting, okay, and the number of layers are 10 here. So as you see here that when we start from 310, so these 3 bias and the total number of neurons is going to be there. So this bias is going to be multiplied by your total number of neurons plus the bias. So 3 times 10 plus 10 equals 40. Now the layer 1 is connected with layer 3. So layer 10, 15. So it means that these 10 neurons, which is like a 1, 2, 3, 4, 5, 6 up to 10, and then the layer 3, remember 1 is connected with layer 3. This is a little confusing, but we made this way. So 10, and then next step there will be 15 of them. So 10 times 15 will be 150 plus 15 equals 165. Now the layer 3 is connected with layer 2, and which is 5. So 15 are connected with 5. Okay, and that's 15 times 5 should be 15, 5 is 75 plus 5. It should be 80. So 80 is there. And then the last is 5 with 1. So 5 equals 5 are connected with 1. So 5 times 1 is a 5 plus 1 is 6. So that many parameters are there. So we have taken the feed forward network in account. We need to look into the bias, neurons per layer, and then finally is output layer, input layer. Okay, so we have set it up, these information which we have to understood clearly. So feed forward network is first, where the information is transferred from one layer to next, and the previous layer is providing all that in the total number of neurons from the previous layers are fully connected to the next layer and providing all the information, and I will be showing you exactly how it happening here. So I will also wanted to show you that bias. What is bias here? So when you start your input network, you have to set up some bias. Everything starts. So right now what you are saying here, that input is equal to input shape and 3. It means what is 3 here? So if you see here that input is equal to shape. If you do not say anything, what input is being considered as of now? And if you remember, if you feed this input to the layer number 1, and if you take the output and you set up as a layer 1 and you define your model and you summarize it, you will see here that your model is 3, 10, 1. It means the bias was used as a 3, which is by default. The next layer had the 10 neurons, and then the final layer has the 1 neuron, that which is the output layer. It means this 3 is used as bias, and how we can validate is we save this model and we try to reload this model, and you see here that 3 is used as a bias here, and the shape is not defined here. As you could see, the shape is not defined what you are trying to pass, because network doesn't know what you want to pass, but at least the biases are used here. What if here, as you see, that the 10 bias is automatically taken here? So why it is taken? It is taken because if you look into the property of dense, the use bias is true, and that's the reason in this label the bias is 10 is automatically taken here. What if you come here and you can say the bias is use bias is false? If use bias is false, we will define input layer and we layer 1 bias is false, and then output connect with layer 1. And now if you look into here, the multiplication is 10 times 3 is 30, and there is no plus 10 because use bias is not used. And now we can reload this, and you see here that in kernel 3 times 10 and bias is not used here. So for that reason, the next layer is 10 times 1, but this layer has the bias output layer, and that is the reason, because use bias is true by default. So when you are starting with your input, you have to set some kind of bias. If you try to use, for example, 512 by 512 by 3, you are saying that these two are your input size and 3 is your bias, and it could be 1, 2. So if you define this, and then your output model summary, now you see here 512 is bias, and then 1 times 10. So the bias, and then your 10 is actually the 10, and then 10 times 1 is 11. Saving, you will see here that your 512 1. So hopefully that should clarify you that how the bias is used and how the neurons really come and calculate your number of parameters. So I will write here that use bias equals true or false is the property. The input layer you have to define the shape, and other one will be bias. And then now how you are going to calculate the number of parameters. So the number of parameters calculation, as I mentioned, is that you always trying to take the 10 times 5 and if you are using bias or not. So for example, if I say default use bias is true and we build this network, let's make it properly. So 1 and 2 and this is 3. So we are defining 3. Okay, this is your summary, and here we are saving it, and let's reload it. So 1 bias is connecting with 10. So there will be 10 neurons in this next layer. So 512 is your image size, and then kernel is 1 bias times 10, so 1 times 10 is your total number of parameters plus 10. So 1 times 10 is a 10 plus 10, 20. We started from here, very first layer. So the input layer is here. So input layer you have, this is your bias. So for that you are taking, this will be your input, this is your layer 1. So input, and then layer 1 has the 10, so it will be 1 times 10. So these are the 10. So 1 times 10 equals to 10 times 1 is 10, and plus bias is 10 here. So use bias is also used here. So it will be 1 times 10 plus 10 because of use bias. So layer 1, and I will make this guy, and I will color bias with, this is your bias, and this is your layer 1. So for the layer 1, 10 bias is next, layer 2 is 5, and bias, use bias is true also. In this scenario there will be, so in that scenario you are going to get how many parameters? The parameters are going to be used by the 5 times 10, so 50 plus 5, 55. There you go. This is the 55. In this scenario, we are going to get this 5. So here will be layer 2, and layer 2 will be this, and then bias is basically 5, sorry, 10. So bias here is 10, bias here is 10, and here is 5. So that's neurons, and it's used as a bias. So it's gonna be 10 times 5 plus 5. So now you have 55 here. The next step will be 15. So here you have 15, and use bias equals true. It means that this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 plus 5. So you add 5 more. I will just make like 15 here, and then bias will be 15. So in that scenario, we need to get, as you see here, 15 times 5 plus 15. Simple math. So this will be layer 3, 5 times 15 plus 15. That will be your layer number 3. And if we look into the layer number 4, so layer number 3 and then layer number 4 is your output layer, which is just 1, and it also has the bias. So if you see, layer number 1 still has the bias as 1, so it will be using 1 and just 1. So 15 times 1 plus 1 plus 1. So it will be layer 4, or it will be output layer. So this is the output layer. 15 times 1 plus 1. And that's where 16 is. So this is how you are going to get your parameters calculated. What if you had no biases? If this whole scenario was when the use bias equals true. This was the important part for our this whole, everywhere you are going to see the bias is used everywhere. Bias is equals true. What if I take this whole network and I convert this to bias is false, and this will be our use bias is false, use bias is false, and here, so let's see these first three. Define network, 1, 2, 3, 4, output. Let's model summary. Now you see here that 1 times 10, 10 times 15, 15 5s are 75, but only this one is a 15 times 1 plus 1. So 16 is there because we still have the bias here. What same thing is going to here, that if we try to save this model, reload, and as you see here, no bias, no bias, no bias. There is bias here. And if you start from here, we are already taking 1. So that's 1 times 10. So this is how everything is being calculated. What if you take this and you say use but is false? Oh, sorry. Output, and then you define again model, and as you see here that it will give you error. So you have to, there you go. Now your model is going to calculate properly. So parameter calculation, I have explained you how it works, and input, neuron and output, how the relationship between the parameters and then the calculation is going to work, and that is for feed forward network. That was very important for you to understand the role of bias in whatever scenario. Even if you are using this, the model definition, and then you are adding layer, that is exactly going to work for you. So for example, if you are defining a new model, here you are save model. Let's come back here, reload your model. As you say, bias here, bias is using, and I think the reason is that because here 3 times 128. So our 128 is the neurons and the use as a bias too. But here you could say that you are not using the bias, and then define again everything. Define, save, reload. And as you could see here that your input is 512, 512, 3, 3 is used here. So 3 times 128, and after 128 there is no bias. So 128 layers is going to multiplied by the next, 128 neurons times 10, 1280 plus 10, because there is still bias is going to apply here, because use bias equals to true is here. If you do not want it, you are going to say, okay, I do not want. And if you look into here in this, you will see that the use bias is true. So use bias parameter is true. That's why the neurons are 10. And if you say here that use bias is false, let's define again. Model is saved, reload. And as you could see here, 128 use bias became false. So role of use bias, you have understood how these different networks are created based on how the bias is being used. If you define this way, this will become your bias. So bias is already been added if you do not define anything. So for example, you say I'm creating a new model, input has no shape, and then if you try to add one more layer, and as you could see here that input of 0 layer is incompatible with the layer, because you have to tell something. So you can say I'm going to start with 10, define a model 10 and dense layer, and save your model, reload. As you could see here, 10 bias is used, and that's became 10 times 1. If you do not use bias here, it will not use bias, but this is your output layer, because that's it's here. So if you try to say that I'm not going to use the bias here, define, add, last, save, reload, and as you see here that use bias is false. There is only layer, and output shape is 1. So okay, so we are already using. I mean that if you will not define, it will not work. You have to have at least one of use bias or not. So you have understood the whole story behind bias, everything. So we have gone through that one too. So that was another part important for us to learn that very well. In the next step, what we will do is that we are going to use a pre-trained model. And reason why we are going to use the pre-trained model is that first I will show you how you can get a pre-trained model and just understand it. And if you know what kind of model it is, how the input layer is defined, how the output layer is defined, and what is in between, how you can use it. And that would be our example. So there are several pre-trained models. So first thing what we will do is that we will create a new Jupyter notebook, and our objective will be to pre-trained ResNet 50 model. So we are going to use this model. This is our location. So if you see here that Keras application is a collection of all these models are available, and you can look into a list of all these models, and when you look into a particular model, it will say what is the size of model, the accuracy, top 5 accuracy if you are trying to define the top 5 classes. If you would want to know how many classes are there, it's trained for 1000 classes. The list of classes can also be probed into that total number of classes, like what kind of predictions it could create for within the image. So that's it has. If you look into the total number of parameters, these are the total number of parameters in the ResNet 50 is 25.6 million parameter. So if you look into how that number came, that is exactly here the total number of parameters what we have calculated, and when we were building our model this matrix. So here see total parameters. So the each layer we calculate them depending on bias and the number of neurons. They keep multiplying plus plus plus, and all the way you are going to get the total number of parameters. So this is what total number of parameters, and the depth we are looking into how we can do. So if we can load this ResNet model from Keras and has ability to see, we can look some of these values and we can evaluate it. So let's look into here. So I will be, so rather than typing a lot, I have this template available. So I will be copying and pasting and I will explain you. That would be faster. So from TensorFlow, Keras applications ResNet. So Keras applications ResNet. So if you look into the documentation, so we have TensorFlow Keras applications and here is your ResNet. So this is what we are using and here is the ResNet 50 and these are the parameters for that. So this is your ResNet and we are importing ResNet 50 which is defined here. Okay, the next step, we are just importing Keras layer input. So after we have imported the modules, so we have this ResNet and then based on this definition ResNet, we can say we need width ImageNet, and as you could see here, this method is called, but we need to store this method in a object, so our base model. So this is our base model available now. Now if you would want, we can use this base model and we can save it and we call it ResNet 100.h5. And if you see here, ResNet, this 98 meg ResNet h5 is downloaded now in our local machine. So if we would want to see that network, we could say netron.stop. So this we need to stop in their respective shell. So netron.stop. So this 82 should stop. Okay, then come to 81. 81 is stop. Okay, now we could use start, load this ResNet model and 8081. And as you could see here, whatever model we have just downloaded, you could work with any of these models. You download here and as you are keep going, the number of multiplications are start happening here now. So the number of parameters, and as you are going to go, the depth is also being, so this is the depth, and as you are keep going, this is your depth is. So if we try to calculate, we will be able to find the total depth is 107, and that is all you will be able to calculate, and where the use bias is then, and where the number of, as you see here, this is our last. So the last class has the output equals to 1000. It means this model is trained for 1000. That's why it's the output is returning as a 1000, which is similar to our definition where we will returning output as a 1. So here the output is set to 1000, and the how you could get it, you can say that for the base model dot output shape, and it's going to tell you it's a 1000 classes. If you will take base model input shape, this is the 224 224 3. It means the input is like this, and we go all the way top, you are going to see the 224 224 3. And if you look into the next layer, which is the convolution 2D, and if we look into here and layers, we have Keras, and we can look into the layers, you will find conv 2D layer type. So there are all kinds of layers and manipulations are happening in this, and that will be part of our next tutorial, where I will going to use majority of these layers and explain you more details. So but at least this way you are going to get a lot more information about what is a pre-trained network, a pre-trained model is look like. So this is our input shape. So it means that if we would want to use an image to predict using ResNet that what kind of objects are identified in this image based on ResNet 50, we have to select image size depending on this 224 224. If you choose something else, then you need to translate that to the exact input shape, because this is what this ResNet is trained for, and ResNet will give you 1000 classes. Now we can set up our input. So I can say input shape is 512 512 and 3. So that is our input shape. Now we can define our inputs equal input, because we are using this input, and we are passing this input shape. So this is our inputs, and then when we are using this base model, we can define that the input shape is basically the inputs. So after it, now our input is defined, so we could say that input tensor image will be this inputs, so inputs, and that's our base model. So we have set it up again, no change, everything is same. Now you see here that because of we changed our input shape, it means that we could set whenever we are going to use the input image, that should be size 512 512. So we have changed that input type by passing the input tensor. If you would not have given, you already saw that that was the 224 224, and if we try to save this right now, it's saved, reload, it became 512 512. So you are downloading the model, so weights are downloaded, but now you are start manipulating your model also. So that's one thing. Now we are going to take an image and try to detect what kind of classes it can find. And same thing, if we have base model, if you would want to see the base model summary, you can say, so this is your base model summary, and what you are seeing here in right side is exactly you are getting here. But again, as I see that here you have way more clarity about what is going on, how everything is looking, rather than what we are seeing here in Jupyter Notebook. That image is available, so bicycle kid is available here. So we could use that image now. So we need to have bunch of libraries. So let me load those library and I will explain you. We are importing NumPy, Keras pre-processing image. So we could process image using Keras library. We don't need to download any other image. We don't need to import anything else for that. If you want to show the image, we are using matplotlib. So we could use the plot where we could render our image. Then after, we are using the pre-process input and image Keras application ImageNet utils decode predictions, and I will be explaining you step by step. So let's, as you could see here, we are loading this bicycle kid image. So this bicycle kid image is available here. So we are loading this bicycle image and target size, and we are making sure that image is size of 512. So this became 512 and 512 size. So that's one thing we have done. Then we are just showing that image using matplotlib, and then after using image, which is the pre-processing image, we are converting image to array. So this image is actually now array right now, and then we are taking the image and then which is 512 by 512, stretching it only on axis x. So it's 512 times 512 is all what you have. So if you look into here, you are going to see this is your image, all stretch based on x-axis. The next step, we are taking the image and pre-process input. Let's see what your image became now. So your pre-process input was used here, ResNet. So whatever you are trying to process, it has to be understood by the network itself. So that's why this pre-process input, so the NumPy array was fed into pre-process input, and it became in a format which is understood by the ResNet 50 model. Now you could perform the prediction, because now this image array can be understood by the ResNet model. So now you are using the base model with prediction, and you are saying that, okay, pass this image and generate the predictions. So prediction started. Let's look into what the predictions are. And here is the collection of all prediction. So out of 1000 class, for each class, prediction is stored here. But now you need to find the top 5 prediction. And that's where you are going to use the decode prediction. So decode prediction we have used here. As you see, decode prediction is a utility part of ImageNet utils, and out of the image which we have given here, it tells that it's could be moped, 30 very small percentage. However, the mountain bike has the highest available percentage among all of these. If you decide top one, is gonna be mountain bike. Top 5, and if you would want to, process it in any other way, you are going to get these results. If you would want to run another prediction, you predict again. These are the prediction. And if you will try to change this, and one more time, if you see here, exact same prediction. So you could change image, you can bring another image there, you could process it, but the steps would be the same. You load the image, convert to array, then stretch that image to axis 0, and then pre-process it so that model is understood based on model requirement, and then use the predict method on the model to predict it. And that's where your results are. So you have seen that how we were able to collect the information about a pre-trained model, and we were able to process it. There is one thing I wanted to show you, which is very important before we complete today's tutorial, is that the concept of fully connected layers. In the ResNet 50, if you look into this documentation, you see include top equals true. So when you do not define, you do not set, the include top is always going to be true. That's where your base model was. If you are defining include true, it includes the fully connected layer at the top of the network. So neuron in the fully connected layers have full connection to all activation in the previous layer. So it means that whenever the activation is really being used, so for example, here is used ReLU, here is used ReLU. So all that fully connected layer, it means that the activation functions are connected in a way that the propagation of the information is always available. And how we can prove it, I'm going to show you a little differently. So I will try to use this base model, and I will call it, it's not fully connected. So base model, and I will call it not connected, and I will set include top equals false. So the base model NC is not fully connected. And if we take this base model NC and here, and then when we are trying to predict, we try to use base model NC dot predict IMG, and we just call it not connected. So NC, now you see here what you are seeing versus predictions are. Okay, let's try to take this and try to decode the predictions. So now you are going to say the decode prediction, okay, top equals 5. And you are going to say decode predictions, expect a batch of predictions, a 2-day array of shape, found array with 1162048. And that's what's a very big difference when you are going to include top equals true or false, because the fully connected layer will be able to translate your predictions correctly, because the information is really being told. Connected layer have full connection of all activation in the previous layers. So I think in layman term, you can understand that it is very important to have the fully connected layer base. Otherwise, not only that, if you try to save the model, it will be a smaller model. So if you take the base model NC, and if you try to save it here, and you call it ResNet 100, you say not connected, you save it here, and if you look into here, non-NC, which is like a 90 meg out of 98 meg. And if you look into the definition of ResNet 50, which is 98 meg. So it means you are getting the fully connected network. If it is not fully connected, it's a smaller size. So that's one very big thing you need to understand. And if you would want to see the load, then you could reload the fully connected. But again, it's about 107 depth, 107 depth. So if we want to understand the fully connected, we have to go a little more deeper. And I would say that that's a really good time for us, that we can extend this tutorial for next time, where we are going to learn even more detailed information about these neural networks, layers, and activation function and definition. So today was just a starter for you. I know I have taken time, but reason I have taken time because I wanted the beginners or the early adopters who are trying to learn the neural networks, they could learn effectively and correctly. So let's recap very quickly. We started with a very simple neural networks we added the input, output layers, and then using the biases, the activation function, we build our network, and side by side, we also visualize our network. After that, we also use a different way to creating a network by defining the model. So creating network. So that was one way. And then here, the order is very important. Whenever you are going to add a new layer, that will always going to be added at the last, because the linkage is not defined the way you are defining the previous way. So that was a big difference. Rest, the type of the layers and the connectivity was pretty much same way. Third step, we downloaded an existing network, ResNet 50, and that was we got from Keras.applications. And my suggestion would be that please try to download any of these network and try to experiment by yourself and make sure that can you do a VGG16 image prediction or ResNet 152. Try whatever you could do, because that is going to help you learn a lot. So that what we have completed, that was another thing. And our objective was that whenever we are dealing with this network and model, we has ability to visualize them and understand them. We also understood the parameter count, how the parameter count is created, how the links are created for these Jupyter notebooks. So Jupyter notebook related with today's tutorials are located here in this Python project, deep learning neural network. I will add the readme here and attach a couple of these images also. So that will also going to help everybody. So that's all we had for today's tutorial. I hope you have enjoyed the content, and I'm going to look forward to see you in my next tutorial. Until then, thank you so much. Thanks for your time. Please like it, share it, and subscribe it.